Hi, everybody. Welcome to today's session. Looks like we have some people straggling in, so we're going to give everyone a minute or two to join. We have a few more people coming into the session. Just want to give our guests a few more minutes to join. We'll get things started in about a minute or two. All right, looks like we've got a good group here. I'm sure we'll have a few more join as we get started. But I want to welcome everyone to today's session. Thank you for taking the time to join us today. If you're not familiar with our Torque Talk live streams, we hold these once every month. They're generally around 30 minutes. We created these as an opportunity for our community to see how our products solve specific problems, right? It's also an opportunity to see some of the latest functionality in action. And it's your chance to submit specific questions, right? So if you have anything you want to see or any questions about how this functionality works, you can submit questions throughout the session. I will be watching those and making sure our speaker addresses any questions that you have. So that's one of the housekeeping things I always like to remind everybody. These are not formal sessions, right? This is an informal, open conversation. So if you have any questions at all, submit them through the Q&A, and I'll try to make sure that we take a few minutes to answer your question. Our speaker today is Yakir Levy. He is a software architect on the Quali team. He should be able to answer any questions that you may have about Torque. Today he's going to give a deep dive on streamlining Day-2 operations to improve performance, cost, and security for your environment. So I think you've heard enough from me. I'm going to pass it off to Yakir and let him take it away.
Okay, thanks, Colin. Welcome, everybody. Today I'm going to talk about automating Day-2 actions in live production environments or in more general Day-2 operations. I will explain what it is, why do we need them, why it is important to perform with the best practices, of course, and how Torque help you to implement them in the best way, and all the capabilities of Torque that go under this definition of Day-2 operations. So let's okay. So the intro will be about Day-2 operation. After that, I will give some basics, terminology and definitions of Torque, just to be in the context to understand the basic entities like Blueprint and environments. And then, of course, I will focus on the capability that go under Day-2 operations, mainly workflows and also EAC. I will explain what it is. Then I will talk about some use cases, real world use cases. And then I will, of course, demo it in our platform. So, Day-2 operations focus on managing and maintaining the environment deployment, which is often automated through ISC. Okay, so we are talking, of course, in the context of a DevOps environment. Right, you have your collection of resources provisioned on the cloud or whatever it will be, right? And now, if we talk about like the phases of how environment evolved and developed, okay, so we can say we have day zero. Day zero is when you prepare your configurations, prepare your definitions, your YAMLs, just plan how you want to start your environment. Day one is when you launched your environment, you deployed, and now you have environment up and running in your cloud on all the resources, your applications are ready to use. In most cases, this is not enough. Okay? In most cases, if it's a long-running environment and even for ad hoc environments, you will have a life cycle that this environment will go through its lifetime. Okay, you want to do some perform some operations on it. So what's some of the stuff? Okay, so key activities include monitoring, scaling, code change detection, code updates, and others. Okay, so for example, you have an application, and the application code advanced in the source control, and now you want to update this application without terminate your environment. Okay, on a live environment, you want to update the code. So how you do it? Okay, or let's take it a step further. You want to automate it. Okay, or even a step further, you want to detect if your code in the source control is updated in the branch, and to do it automatically, that it will detect the change and then pick it up and update it. Okay. Other stuff include other operations include drift detection. Okay, so drift is when your resource in the cloud diverge from the definition. Okay, so you want to know it. It can be caused from mistake, human interaction. Okay, usually if you deploy and manage something through code, so it should stay like this. So you want to detect the drift. Okay, sometimes drift can lead to inconsistency in the environment, and to a point you cannot terminate it. Okay, so you want to detect it, and even after you detect it, you want to reconcile it. Okay, so how do you achieve it? Those only some of the stuff that goes under Day-2 operations. Other stuff, of course, has custom actions, like if you have an instance or a Kubernetes deployment and you want to scale it down or scale it up, for example, through times of a low load in the system, you want to scale it down, and when it is high load, you want to scale it up, and all this while an environment is up and running. Okay, implementing these actions without disrupting the stability and performance of a live environment can be challenging, right? So this is a very a gentle thing that you have to make. There are several requirements, okay, from a Day-2 operation that you have to abide to. Okay, you want to keep the environment consistent, as I said. You want to keep it reproducible. Okay, you want the ability. It's important to keep the ability to reproduce environment, the actual state, the current state that the environment in for any given moment, in case there's something happen, like a disaster or something like this, or you want to start the same environment on the same cloud. So you cannot just do any changes you want on an environment and expect that it will keep reproducibility. Okay, so Torque offers a broad range of capabilities to automate and improve the process. So all the stuff, all the operation that I just mentioned, and much more, all this implemented in Torque in a built-in way, and all this go through under Day-2 operation, and the focus will be today on the workflows. Okay, on workflows and EAC, mainly workflows. What is workflows? I'll get to it in a second, but just an overview of the general what is Day-2 operations, and what are the requirements of it, and why is it important to do the stuff in automated way, and to use the best practices, which is what Torque offers. Okay. Terminology. Okay, so I will cover the basics, some of the basics of some entities in Torque to have a context. Okay, so blueprint. The blueprint is a representation of a set of resources, configurations, and variables that define the infrastructure and runtime environment for an application or service. The blueprint typically includes details about the hardware and software components that make up the environment, as well as any dependencies or external services that the application or service relies on. Okay, so in a simple way, a blueprint is a template, is a definition. So just like you have a Helm chart from which you deploy Kubernetes deployment release, right? So you have a blueprint, which is the definition of the environment. Once you have a blueprint, you can launch from environment, And the blueprint define the entire structure of the environment. Okay, what are the components that the environment composed of? How they depend on each other? What are the dependencies? How the data flow? Okay, which means if I have an input, output from the environment between components, between subcomponents, or from different configuration endpoint of Torque. Okay, you have the entire ecosystem of Torque that eventually you can use it from a blueprint to the favor of the environment that you launch from this blueprint. So this is an example, okay, of a blueprint, a very simple blueprint. So what it is just a YAML, okay, just one YAML, a very simple schema, simple syntax. Again, I will not go too deep into it because this is not the focus, but just to have some sense about what is a blueprint. So I have inputs, outputs that are defined. That there will be the inputs and outputs of the environment, and the main point is the grains. Okay, a grain. The grain is the smallest unit of deployment of environment. Okay, so environment is composed from one or multiple grains. It can be a lot of them, and with a dependency relation between them. The dependency is DAG, right? Directed acyclic graph, and they have been orchestrated as in the environment as you stated here. Okay, so I have here in this case I have like here two grains, one of kind of Terraform. Okay, each grain has its own provisioning provisioning tool or provisioning technology that it uses. So in this case, I have Terraform and some definition. What is this? What is the module? What is the module defined? The agent is more in an operational level. Is the hosting environment where the workloads run? Okay, the workloads run on the user side with basically Kubernetes or Docker. It has inputs and outputs. Okay, same, very similar for Helm. I have another one that provision Helm Kubernetes. I have again source agent, and some of the fields are common. Some of them are specific to a specific technology. Eventually, this blueprint, this is what it defines. Blueprint support variable-based evaluation with Liquid, which is a very well-known templating language, which give you the option to dynamically set values, okay, that will be evaluated only in later phases of the deployment. This is a blueprint on very short. Environment, okay, environment, of course, this is the core of the product. An environment is a collection of components that are provisioned, deployed, and orchestrated to perform the task. Okay, so environment is all your configuration, all your infrastructure where your application runs. It can include the operating system, all the compute, network, and storage, everything that you need to consider part of the same environment. It can be on the same cloud, it can be different cloud, it can be any infra provider, vCenter, VMware, it can be your laptop. Whatever your provisioning, whatever it is. Torque environment is an instance of a blueprint, okay, as I said. So it's either blueprint or EAC. EAC is environment as code. I will get to that after, but those basically are the two sources for environment. The essential difference is that blueprint is a template, and you can launch from the environment. And after you launch the environment, it is detached from the blueprint, and EAC is the GitOps way to manage environment, which this one I will demo, the EAC part, how to manage the environment via code, via source control, which means the instance is connected to the YAML of the EAC. but they are both EAC and Blueprint. They are both YAML with the same schema, same syntax. And this is one of the benefits here. Even when I get to the workflow, it also is a YAML, and all of them are very similar in the schema and the syntax, so you don't need to learn different languages. Environment is a state managed by Torque, of course, right? Deploys and orchestrate a collection of grains with a tag dependency. As I said, okay, the environment is the representation, is the instance of the blueprint. So the same terminology of grain is the definition, the grain definition, and the grain instance is in the environment. The definition, the blueprint, the instance, environment. Support different kind of IC tools. Okay, so a broad support for all kinds of provisioning tool, Terraform, CloudFormation, Ansible, much more. Support various capabilities. Okay, so above all the added value the Torque give you, of course, all this goes to your environment. Okay, under governance you have policies, and policies in several layers. Policies can be what resources am I allowed to provision in the cloud. Okay, you can allow users to provision only specific resources, and also a policy in a level of what action can I do in Torque, approval request, tagging, which obviously helps a lot to tag your resources in the cloud for management, cost, etc. Asset changes, as I talked about, asset changes is how we keep track of code changes in your repository, and we can tell you that your code is advanced and now you can update it. The code is deployed now in the environment. Secret management, credential management, and all the layers that you get from Torque when you deploy the environment. Okay, now we're getting close to the focus. EAC. What is EAC? EAC environment as code is the GitOps way of creating and managing environments. Okay. EAC is how you will create and manage your environment through GitOps, through Git, your source control. It can be GitHub, it can be in GitLab, Bitbucket, and we support a different kind. And this is, of course, usually the best way, okay, to manage the environment. You know, everything is code, so everything, all the changes are tracked. You get it from the source control, right, from the versioning. So you can revert it back easily. You can do changes, and you know everything is reproducible. You get all your permissions from the source control, so you know exactly who can change your environment. Not anybody can go and change it and modify it, only according to who can push to the branch. It will be managed by PR or the process with the reviews and stuff. So you get all these benefits from EAC for a resource that managed by code. Okay, so as I said, managed via source control. EAC is basically a YAML. It's called environment YAML, which is very similar to Blueprint, but it has some sections that are different because the EAC is actually the desired state. Okay? It represents the desired state, and environment is the environment itself is the actual state. But the syntax and schema is similar to Blueprint. You don't need to learn a new language. A single YAML defines a single instance of the environment, of course, because this is GitOps. So if you define one YAML, so you will have one environment, unlike Blueprint, which from one Blueprint you can launch multiple environments, right? Because you say it is detached. So this is AC. Of course, in the context of Day-2 operation, the entire life cycle, the entire the updates that your environment go through, it will be through the source control, and of course you should not update it outside. Workflows. Workflow, a stateless automation script to perform a task in the context of environment or resource. Workflows can be executed automatically by events or manually. Okay. So what is a workflow? Of course, the general, procedural, long-running series of orchestrated jobs, and that have some purpose. Okay. Workflow can be general purpose, or it can be have a scope. Okay, a workflow in talk. Okay, or you can define a workflow, which is a general purpose, and it perform a series of tasks, or a workflow that operate on specific environment or a resource or a specific resource inside the environment, and you get all the integration to the product, to the environment with workflows. Okay. A workflow can be simple as hash check. Okay. And it can be more much more complex. It does a series of tasks, and at the end of it, it produces some outputs, and okay, right, and that's it. Environment workflow, there are several examples. For environment workflow, here we have a resource workflow. That is a workflow that operates on some resource. So, for example, a VM or instance, power off, power on, or restart. Pod, if I want to get a description or scale it or delete it, and lots of others example of different resources. Okay, so some of the examples are already mentioned, right? If I want to scale down, scale up my Kubernetes deployment in a specific times, right? So I can have a workflow automated to run every periodic time, in the morning, in the evening. For example, I can have a workflow that run in the morning and power on the VM. When I start to work, and in the evening when I finish, it power off the VM. And this is the benefit. Your environment can still stay up. Okay? Let's say this is a very complex environment, and you don't want to you want to leave it up, and you don't want to terminate and start a new one. So your environment stay up, but the workflows take care that your resources will not consume too much compute in times where you don't use the environment. Okay, so in case of VM, you can hibernate it, or can just power it off. Okay, so the workflow it is defined in the very similar way. The workflow defined in a very similar way to the blueprint, as you can see. This is again, this is a workflow definition is a YAML with a very similar schema. You have inputs, you have outputs, and you have again grains. Okay, so grains in this context, there are jobs. The environment, there are usually stateful, right? The workflow is stateless, but you still have a collection of grains that are orchestrated in a certain way, and that perform, it can be simple tasks or complex tasks, and all those tasks are run, I will talk about this a little bit later, they are run in isolated, in container, in a scalable way on your cluster, and yeah. as you can see here, there are special sections that you define for workflow. And what we have here scope. Okay, so the scope is what is the context that the workflow work. Okay, so you can have a general purpose workflow, but in most cases you want the workflow to run on your environment or your resource. So this is exactly the scope. So once the scope is end, it means it runs on your environment. Okay, in the context of your environment. If it's end resource, it runs on the context of some resource in your environment. In this case, it's a VM. This is the scope. In addition, you can configure the workflow. I don't have it here. I have it shown in my in the source control. We can configure the workflow to be triggered by different kind of but different types. Okay, so it can be triggered or manually. It can be triggered automatically on certain period, or it can be triggered by certain events. Okay, those are internal events that, for example, if environment launched, so we can trigger a workflow. So as you can understand, it is very flexible to automate lots of complex use cases that are much needed. Of course, you can replace your CI CD with very complex configurations. Usually the one that tried this blueprint and workflow, this is the producer side, right? This is usually the DevOps teams run them, and it will go through some development and testing, and then once it is published, so the end user can use the workflow, can actually run it, attach it to environment, and use it. Of course, anybody can do it. It's a matter of permission, but there is a producer side and a consumer side. Of course, the good thing here is that everything we saw is code, right? So the workflow defined this code, the blueprint and the ESC, everything is code that sit in your source control repository, and you onboard it to talk, and you can use it from top. Again, so I have here some examples for workflow, environment hash check. I talked about it, so we just we go straight to here. This is some the big picture of what the environment consists of. As you can see in the middle, there is your application, your infrastructure, and the data, and what they require from your application. As I talked about, consistency and reproducibility. Self-service, of course, it's important even for a small to mid to large organization. The user, to simplify the life of the end user. Security governance and scalability, of course, it's always important to everything working cell, workflows and everything should be scalable. Right, the ways to achieve it is through different methodology. It can be automation by GitOps, or everything is code. And in the right side, you can see, like, if you deep dive, you can see all the different capabilities, different features that give you all this auto tagging, update, drift, logging. All those are features you get in talk that goes to your environment, give you the visibility, the debuggability, and the control on everything that involved around your environment. Yeah, I will just go faster so we have time. Demo, I will show now EAC and the workflows. Okay. Okay, so we'll show you an example. This is Docker, this is the portal. And what I see here, this is Git environment. I can see here all my EAC files. Okay, so I have a repository. This is the repository. I have here in the repository all my source files. It's in one place for simplicity, but you can first split it. So I have here under environments directory, I have here my EAC files. Okay, so as you see here, this is simple YAML, very simple, very similar to Blueprint. The defined environment. Okay, so the structure is the same structure. I have a grain, I have inputs, and some section that tell me what is the desired state. And I can see it here, okay? We focus on S3 head. Right now, okay, so just what we have here is one grain, it's bucket, that use Terraform to create bucket. This is what I have. And right now, the state is inactive, which mean there is no environment because inactive is not active. So I will change it to active. Okay, so I just changed it here. And now, it will pick it up. Okay, what Talk does is monitor your source control, and once it pick up your change, it will immediately try to take the desired state to the actual state. Right, this is what the GitOps mean. So as you see, I press it on the button. It brought me here to the environment, and this is the environment. And you can see I have one grain in the environment, one component. It is a bucket deployed, provisioned by Terraform. And right now, as you see, it's launching. And you can browse here to see the different features here, the tags, the updates, drift changes. Again, I will not show all of this. I will be focused just at the right. So you see it finished deployed. Okay, so I have here a bucket. So I have environment up. Now, let's have this environment. I can work with it. Everything is good. And now I decided I want to change it. I want to modify the environment itself, right? So I want to add an object, and I want this object to be part of the environment. I want it to be managed part of the environment, right? I can add object on these buckets inside, but I want it to be managed. Okay, so I had here another grain object. Okay, I just pass it here. And I will also add outputs. I want it to give me what output? The object key. Okay, so I did some change on the YAML, and while it's active, right? So I commit it. Okay, I will go back to my environment, and let's see what happened here. If you go here, you can see the actual bucket that we have here review. Okay. So as you see here, the object I added in my file in GitHub was picked, and now the environment picked the change, and now it again tried to bring the actual state to the desired state, and it's go through updating. So you can see here the bucket will update, and then the object will update too. Here you can see the actual steps. Okay, you can have the logs, really what happened inside the Terraform logs. Okay, nothing is under the radar. You know everything. You can see exactly what happened. And once it is done, I will have here in the quick access. I will have here the outputs, which is the object key. Right now it's not yet evaluated, but right when it finished. Yeah, so I will have it. is supposed to be pretty fast. So I hope it's clear, right? This is the first grant. This is the second grant. Okay, as you see, this is it finished successfully, and I have the output, and I have my environment after modification, and now I can work with it. Of course, since the object is part of my environment, again, it gets all the auto tagging, all the policies, all the stuff that is part of my environment. Now, if I go here and then move it again to inactive, then it will terminate the environment. But I will stop it here and move to workflows. So I want to show a workflow example. This is my workflows, okay? And I have here 3 workflows. And if I press one of them, I can see the definition. And you can see again, it's again the same thing, the same schema. This is the definition. I have inputs, some inputs, some outputs, and what is the workflow? The actual workflow composed of two jobs, 2 grants, but they are stateless, so there are 2 jobs. One is of type shell, which runs some script to extract some data, and the other one is the more interesting is the health check itself. It's also shell. It runs a different script. This script is also in the same repository. IC samples. Okay, everything is there. It's under script, service health check, and this is just a very simple health check that do some REST request via the endpoint of my service. Okay. The service can be anything, of course. So I will show you how I use it. It depends on what environment you use it. It can health check. It can run a health check against it. Okay. So this is my workflow, a very simple one. The definition of it, of course. And what I want to do is I want to launch an environment and attach this workflow to the environment. Okay, so what I have here is the definition, what I talked about trigger. So this workflow can be triggered by two types. Okay, one is manual, and the other one is a cron, which is periodically. So I'm saying I want the ability to trigger it manual or every 50 minutes. Okay, because I want to run the health check every 50 minutes. Okay, so I go to Blueprint and I launch Helm WordPress. Okay. This is a blueprint. This is a standard launch of a standard environment. Okay, I can give it the release name, demo release, some input, the namespace, tags, and workflow. Okay, so here is the interesting part. Here I can attach workflow, so I can choose this one and disable. I will choose to attach only the end of check workflow. So you can see here it's every 15 minutes, and I can even edit it here and change it. And when I launch it like this, it will launch the environment with this workflow attached to it that will run every 15 minutes on the environment. Okay. So the environment itself is, I didn't show the blueprint, okay, but it is simple WordPress application deployed in Kubernetes. It's simple Helm and taken from Vietnam, I think. And it has a workflow. Now, because this deployment can be a little bit long, so I'll just go to one that I already have ready. So this one, okay, at the end of the deployment, this is what I get. I have the environment of $1,000, and here I can go to workflows and Okay, okay, maybe I had some small mistake there. But here I can, as you see, the workflow is here, and fast check workflow. And as you can see, the next execution in 4 minutes, which means it runs every this specific runs every 5 minutes, and this will run periodically. And also I have option to execute it. So I can execute it manually, or it will run periodically. And I also can delay it. Okay, so if I want to delay it, I can choose that. If I don't want it to run in the next time it's supposed to run, so I can delay it. But yeah, first I need to give it some time to finish. Meanwhile, I will show the other example. The other one is attach detach. Okay, this is a little bit more complex scenario of attach detach of a volume to environment. So I have here 2 different workflows. One for attach a volume. Sorry, not environment. The volume to a EC2 instance. So I have here a workflow. Again, quite simple to attach a volume to EC2 instance, which have 2 grains, 1 shell, and the other one is Ansible, as you see here. The Ansible is an Ansible playbook that attach volume. It's a simple playbook they can just download, and you can use it from the workflow. Okay. So I have 2 workflow. The detach is very similar how it works, and I can run environment, the blueprint that it has EC2 instances like this one, from EC2 instances with those workflows attached to it. Okay, so again, I start a new environment. I give it some inputs that already default is fine for me. I go to workflows, right, and I choose only those attach and detach. So those workflow they will not run periodically, but I can run it manually on the environment, whatever I want, whenever I want. Okay, so this environment is a little bit more complex. It has a database and then 2 instances, okay, on AWS, right? So one database and 2 instances that depend on it, and I want to attach a volume to one of those instances. And again, because this can take some time to deploy, I will go to another one that I already have up. And I can go here and attach and run a workflow that attach a volume. So I can go here. I have here the resources. Okay, here are the resources of the grain. This VM, this is VM, and this is VM. I can choose one of the VM. This is a VM. Once I click on the VM, okay, I click on the VM, so I can see here. This again, wait a minute. I can see here several workflows that can this one actually this power on and power off and restart, and I can run those workflow on the CVM right if when I want to operate on the CVM. Okay, if you want to power off or on, this is what I have here. Let's see what the status of it. This one takes a bit of time. Yeah, but basically, yeah, this one will take time a bit, but basically, I showed the basic principle and how to start a work, how to build a workflow, how to run it, how to detach it, how to attach it to environment. I can also go to the workflow here and manually run it on any environment that I want, even without attaching it to the environment. I can just choose one and then choose the grain, right, the instance, and then the resource, my VM, and I can run it. Right, I choose the touch. So yeah, attach. And now you can see here in the workflow execution that this workflow now running. Okay, so the view is very similar to environment. As you can see here, I have two jobs. The first one is the helper, and the second one is the attach volume. You can see here the logs, and once it is done, I know that I have a volume attached to the instance, and I will have here the volume ID. Yes, you see here, run playbook, just run the Ansible playbook that attach the volume. Yeah, it's completed. And now I have here in the output, I have the volume ID here, and I can go to my account and see this volume was attached to my instance. And when I finish with it, I can run the workflow that detach the volume from the instance. Yeah, and that's it.
All right, thank you, Yakir. I think we're starting to run short on time, so I'm going to jump into some of the questions that we got throughout the session, if that's okay with you.
Yeah, that's right.
We did have a question on what kinds of source control we support for storing environment files that you showed early on in the demo.
Yeah, that's a good question. So I have here a section of repositories. In the repository, this is the first thing, of course, I need to do to configure before I start any of it, like launch environment or workflow or something. So I have various types of source control, right? I have a Bitbucket, GitLab, Azure DevOps, code commit, and CloudShell, which is internally. And each of them, of course, it's for environment YAML or workflow or any other kind of source.
Thank you, Yakir. We did have a question if there is support for modular structure when building environments or workflows.
Right. So yeah, exactly. So that's a good question. Yes, we support a nested blueprint, okay, or a nested environment YAML. So this will give you for example, okay, I will show some example. You can, and it is of course the best approach always, okay, to split your models, your configuration to modular, just like you have in Terraform. You usually don't have one big, you split it to submodels. So here you can also split it to YAMLs, okay? Both for workflow and blueprint, you can have a grain of kind blueprint, which means that it will use the blueprint that it points to as a nested blueprint, okay, like a submodule, and then in that way you can split your configuration and compose them in any way you want in a very modular way. Yeah, so this is supported both in workflows and environments and AAC.
Great. We have time for one more question here. If anyone has any others, please send them through, and we can make sure we follow up over email after the end of the session. But we had a question asking how this is any different. I think talking about workflows, how Torque workflows are any different from other workflow engines.
Okay, thank you. That's a good question. So there are all kinds of workflows engine, right? Each one has its own purpose. Torque implement its own workflow engine. It's performance-driven, highly scalable, and fault-tolerant. It uses the same operation engine that is used for the environment deployment. It uses the user hosting cluster or a Docker for the workloads, for the pods that run the provisioning technologies. And this is from the operational level, right? In the functional level, the workflow in Torque, beside, of course, that they can be general purpose, they can also, as I showed, be in the scope of environment or a resource. So if you already have environment, you deployed with Torque, so you get all the benefit of the integration to those environment resources that available to you from your workflow code. Of course, you get all the other capabilities and features that Torque give you as governance, policy, configuration, all the settings that you have, parameters, credential, secret management, all this layer, right, that Torque give you. So if you use it, if you already use Torque for your environment, this is only logical that you run your workflow from it, right? This is the purpose. Torque as a control plane, so you can have both state, which are the environment, and stateless tasks, which are workflows to manage your pipelines, CI/CD pipelines, or any other job that you want to do.
Okay, I'm not seeing any other questions here. I want to thank everybody for taking the time. Yakira, thank you for that detailed demo. It was really, really valuable. I want to send a special thank you to Corey on the back end for making sure everything works correctly here. If you want to learn more, you want to try this out in first-hand experience, go to quali.com and visit the playground. That is the public-facing version of our Torque platform where you can go in, launch environments, actual environments that we've created in the platform, and see samples of our reports, some of our other functionality there. Thank you again, and have a good day.
Thank you. Thank you very much.